Hello, and welcome to the 2018 Logix Awards. My name is Andy Lennox, and I'm going to be your Master of Ceremonies for the presentation today. We've got people with us from across North America, and thank you for choosing to spend your time with us this afternoon. We do the Logix Awards every year, and for us, it's a pleasure. It's always great to recognize the customers, the homeowners, the builders, that work with our products and the ingenious ideas they come up with. We really appreciate as well the opportunity to recognize the fine work of our Logix territory managers to support those programs. And we also feel great about sharing some of these things that are being done out in the field that you as a viewer can choose to put into your project if you see fit. So it's just a fantastic thing to do. So let's just get started and let's just get going. First of all, this presentation is sponsored by ICF ProLink, and ICF ProLink is a really great database that matches incoming ICF leads with ICF experienced installers, architects, designers, and engineers. If you haven't visited ICF ProLink, please do so. Okay, so we have got three categories this year: small residential, large residential, and commercial. Small residential is defined as homes under 3,000 square feet. Large residential is obviously homes over 3,000 square feet. And we've also got a commercial division as well. In each of the categories, a winner and a first runner-up are going to be recognized. And all winners and runner-ups are going to receive a Logix Awards plaque. And that plaque will be arriving at your location sometime in the next few days, and the use of the commemorative email footer that you see on screen that you can use at your discretion in any marketing and promotion that you choose to do. So let's get to it. The first category that we're going to be profiling is small residential. And small residential is a great category. Often in this category, budgets and space are limited, so the focus is on ingenuity and performance, and so there's always really interesting things to see. So our first runner-up in small residential is the quiet Lakeside home, supported by Evans and Tedham Lumber, Logix dealer in Calgary, and Dan Ruthke, Logix territory manager. This home is located in Sylvan Lake, Alberta. The owners drew up their plans by hand, actually, and sent them to a designer who actually put the plans together then for this 2,600 square foot lake home. The lot was originally flat, but the design called for a walkout, so there was a lot of soil issues. There had to be a lot of deep digging. And as you can see, the difference in the elevation of the footings. They had soil issues as they started digging. They had to dig even deeper. Walls had to go 6 feet under the garage. With all the excavation, the soil, and given that it was a lake lot, the soil had to actually stay on the lot. So it took a lot of coordination to just keep everything together. This was built in spring/summer 2016. The owners engaged a general contractor of their choice whose work that they really liked, and the GC had not built with ICF before, so the GC engaged a subtrade for the Logix shell install. As you can see, Logix Pro was used to build this project for the below grade walls and the above grade walls. The man hours per foot came in at a very decent 0.098 man hours per square foot in this install. You can see it going up here, and you can see the tremendous view of this lakeside lot. There's the house under construction, but getting there with the roof on and ready for finish. This project actually used heat sheet as well, which you can see in the picture. Heat sheet's a product that we make as well, and it's used under slab to provide insulation. But it's used almost exclusively with radiant floor heating. And here you can see some images that kind of show the essence of heat sheet. Heat sheet essentially is a rigid insulation like any other, but it has this framework of nodules that provide tracking for insetting the radiant tube flooring tubing. So you can it actually allows you to keep a good pattern for your tubing without the need to be on your hands and knees pinning it and creating the pattern yourself. And you can just walk in the tubing, as you can see here. It saves an awful lot of time for the contractor. If you would like to learn more about heat sheet, you can visit the heat sheet website at heatsheet.com. Lake living can be noisy, and in this case, there's lots of reasons to choose to live in a Logix ICF home. In this case, the owners were very intent upon the sound reduction, the sound attenuation properties of the Logix walls. They wanted quiet. Lake living is beautiful, but it can have noise. It can have snow machines in the winter and sea-doos in the summer. There can be music and such. The owners, by all reports, are thrilled with the quiet, and they're actually thrilled with the comfort and energy efficiency as well. So congratulations again. First runner-up, the quiet Lakeside home, Evans and Teddem Lumber, Dan Riefke. Now, let's get to the winner of the small residential category. And the winner is the High Performance Home Up North. Logix dealer, Carruthers Home Hardware, builder and owner, Sunset Builders, all supported by Jeremy Browning, Logix territory manager. Now, when we say up north, we mean up north. This home is located in Yellowknife, Northwest Territories. Now, although it's located way up in the Northwest Territories, the genesis of this home took place on Vancouver Island, where Dave LeBlanc, who is actually the owner of this home and the owner of Sunset Builders, that's where Dave used to live. And that's where Dave first began building with Logix. Life events took him up to the Northwest Territories, and so he decided to build his family home with Logix ICF, as you see here. This is a 2,200 square foot, two-story home with an additional 1,200 square foot basement. This home had to be higher than planned, above the floodplain, than David intended. The basement walls, as a result, are actually 15 feet high. You can actually see them here. Very tall basement walls. Now, the basement walls are 15 feet high, but that's only providing a 10-foot ceiling height in the basement itself. The other 5 feet were mostly just for soil conditions. What's kind of neat here is Dave actually placed every single block himself. And when I say himself, I don't mean Dave and his crew or Dave and his family. Dave placed every block himself, which is extremely rare. He did about one floor per week, which is very efficient. And this install came in at 0.055 man hours per square foot, which is also extremely efficient. So Dave did a heck of a job with that. As you can see, Dave used the gray silver Logix Platinum blocks in this house for an R28. That's the R value of a typical Logix Platinum wall assembly is. Now, Dave also used Logix DRVs. So here you can see how the R value the R values play out with Logix ICF. In our Logix Pro, which is our flagship product line, a typical wall assembly has R25. With Logix Platinum series, which is made with a graphite enhanced EPS, that is the same wall thickness as Logix Pro, but provides additional R value. A typical wall assembly will provide in the order of R28. Now, you can also slide in a Logix DRV panel, which you see here on the inside. So, and the R value of the Logix DRV panel is R8. So what you've got here is Dave actually used a 8-inch core Logix Platinum series, but he inset Logix DRV panels in the inside, so that leaves you with a 6 1/4 inch concrete core. This actually, there's R28 in, it would be typical in the Platinum Series wall assembly. Add the R8 from DRV. This you're looking at is an R36 wall assembly, which is what Dave went for. And you can see this is a shot of the inside of the footprint, the walls going up. You can actually see that Dave actually used Logix ProBuck for the window and door openings as well. And this is a good shot of Logix ProBuck. For many years, the window openings and door openings in ICF walls were usually bucked out with wood, dimensional lumber, or wood products like that. Nowadays, it's very commonplace to see molded foam products such as this, such as the Logix ProBuck used to frame out the openings. The R value in the Logix ProBuck, when you consider the amount of foam from end to end, is about R49. So you can see how that just really adds thermal stability to the whole opening. There's no thermal bridging, and there's no contraction or drying out or air leakage over time. It's a fantastic way to complete your ICF envelope. This isn't Dave's job site, but this is another job site. But you can see where we did some thermal imaging, and you can see how the Logix ProBuck, the thermal image of the temperature of the Logix ProBuck is very similar to that of the Logix wall in the area of 69 degrees Fahrenheit. So you can see that's the thermal stability that you're getting with when you complete your wall system or your envelope with ProBuck. And that's what Dave did. Now, Dave also used another ICF product, and this is the Fortress floor system. Fortress can be used. It's an ICF floor system. It can be used for roofs and floors. In this case, it's used for the floor, and in this case, it was used for the garage floor. So this basically forms the. This is the structure of Fortress being laid. You can see these Fortress members being laid, and now the EPS members over top. And it kind of creates this kind of floor system here. And then over top of this, Dave will pour the concrete. And so what you get is a steel reinforced concrete slab, fully insulated and suspended. Now what Dave did then is he reclaimed the square footage under the garage and used it to extend his basement under the garage. And so that's why he get, normally you'd think a 2,200 square foot home, a 1,200 square foot basement seems inordinately big. And that's because he was able to go right under the garage and extend his basement. So this is something that is a good way to increase living space at a very, very good cost. This is the first home in the Northwest Territories to be EnerGuide rated at 85, which is EnerGuide's a Canadian rating system, and 85 is an extremely high rating. R2000, which is the premium building standard, is an EnerGuide 87, and Energy Star, which is a very solid standard of construction, is 80. This is the first house in the Northwest Territories to get an EnerGuide 85 rating, and the first to receive the $1,500 rebate that comes with getting an EnerGuide 85 in the Northwest Territories. Dave sees a real opportunity here. Dave's next home is going to be net zero, not just EnerGuide 85, but net zero. The Northwest Territories, it's cold up there, but it's sunny. And as you can see, that's a clear sky. And sun is good for photovoltaic. And so Dave really thinks that net zero is very achievable in the Northwest Territories. And so I think that's going to be a fantastic breakthrough to have net zero homes in the northern climate of the Northwest Territories. Dave sees a real business opportunity here. High performance, 2,000 square foot homes, 3 bedrooms, 2 bathrooms. He thinks that's a sweet spot, and that's the way he's going to build these homes with Logix ICF. So congratulations to our high performance home up north, Sunset Builders, supported by Carruthers Home Hardware, and Jeremy Browning, Logix Territory Manager. Alrighty, let's get to our next category, large residential. Large residential is always always seems to be the most hotly contested category in the Logix Awards. And then this year it's no different. We are going to be profiling 2 projects here, but there are a number of projects that were submitted that we just don't have the opportunity to profile that deserve recognition, but we just can't do it. Those projects will be carried over into the 2019 Logix Awards, and you know they could have won. They could have won any other year possibly, and they'll be favorites next year. But let's take a look at the 2 very interesting projects that we have this year in Logix Large Residential. The first runner-up is the old meets new net zero home. This is a home constructed by Otten Constructed, supported by Sam Johnson, Logix Territory Manager, homeowner Stephen Heinrich. This home is a 3,710 square foot home with plus a 1,946 square foot basement. And this home is located in Caseyville, Illinois. There's a lot going on with this house, and I look forward to taking you through this. As you can see from the front, it looks like just a very nice, very regular country home, but there is a lot going on here. As you can see, this is a net zero home, and you can see some of the net zero features coming in at the back, not so much the front of the home, but at the back of the home. You can see the photovoltaic, you can see the shading on the windows, you can see the overhangs, you can see no windows on the sides, and you can see this interesting structure that's called a cupola, and we'll talk about that a little bit more. So we've got a cupola, and what this is a vertical channel that's basically there for passive ventilation. And you can see we've got the 12 kilowatt solar array for net zero metering, and that's actually quite a modestly sized net photovoltaic array for such a sized home. But that's because the home is just so cleverly designed and so efficient. You can, and you'll see a few other things that we're gonna get into more in the future in the other slides. It all starts with the building envelope, and this envelope has been insulated to the numbers. So what we've got is under slab, we've got 4 inches of rigid foam, which is providing an R20 under slab. You can see how they've specified Logix Pro for the below grade, but then Logix Platinum for above grade. So R25 below grade wall assembly, R28 above grade wall assembly. You can see that they've sprayed R50 open self spray foam against the roof sheathing in the attic. You can see also they've got a steel roof for low maintenance, but now you've got the problem of a steel roof, which is kind of gets very hot in the summer. You got all this insulation there. They actually had to double sheet the roof to provide a ventilation layer between the steel roof top and the insulated bottom. So you can, that's a really interesting detail that you might want to consider. Also, you can also see now the passive solar kicking in. 39% of the southern exposure is glass. Double paned windows provide optimum solar gain. They don't have windows on the east and west sides to eliminate unwanted solar gain. You can see the windows are protected by large overhangs, which are designed to keep sunlight in the summer away from the windows. You can see that they've got powered exterior shutters to control the solar gain in the summer. And then you can see these solar tubes, and what these do are provide a channel natural daylight into many of the interior rooms of the house, so without using power. So natural lighting without power. So it's just very cleverly thought out. Now, another interesting thing is the use of earth tubes. Earth tubes are tubes that are buried 10 feet below grade. These tubes run 200 feet long underground. Now, there's you hear a lot and when you're in construction about geothermal and tubes running underground, but a lot of the time they transport liquid, which is the basis of radiant floor heating systems. These tubes transport air. So what's happening here is that air in the wintertime is passed through the earth tubes, which are 10 feet below the ground. The air is naturally conditioned by the heat of the 50-degree or 60-degree temperature of the soil. So when it gets to the house, it's been partially conditioned without expense. And that's part of the cleverness of this. And you can see how the earth tubes have been installed with a 2.5% downhill grade. The reason that's been done is to drain any condensation that might occur. So once again, you don't have condensation being drained out by some sort of pump that can break down. It's the law of gravity that's draining the condensation. And there's the whole thing. You can see this cupola, which is just a natural ventilation stack at one side of the home. And this is the core of the natural ventilation. It's the engine behind passive ventilation. Basically what happens is on cool days, the chimney effect pulls air into the house. Air exhausts out of the house, pulling air through the earth tubes, conditioned air from the earth tubes into the house. And it's just all natural ventilation. It's not being moved by a pump that can break down. It's being moved by the laws of physics. And that's part of the really interesting design of this home. There's kind of an overview of how the owner of the home, Mr. Heinrich, designed this. They do have additional heating, obviously, but they use a very modestly sized 4-ton variable unit heat pump, and that will do what it takes to condition this very large home. And that's because of all the other natural things that they've put into place. And there's the hot water heating. They also capture rainwater with cisterns and such and reclaim that. The whole thing, it's all very cleverly done and all using very common sense practices that will not be prone to break down over time, which was a big priority for Mr. Heinrich. But it's made possible. You have to have an extremely airtight and energy efficient shell to make this all work. And that's the ICF, the Logix ICF shell. And this is just kind of an illustration of how the ICF shell works. And I'm going to show you a lab test that was done to compare an ICF wall versus a typical 2x6 wall. And these are 8-foot by 8-foot wall assemblies. And this was done in a lab. So it's not a model, it's an actual physical test. So those wall assemblies would have been put in a chamber. And this would be the end view of where the wall assembly would be. So the wall assembly would cut the chamber in half, where one half would be a warm space that would be maintained at 70 degrees Fahrenheit by a heat source that's run on a thermostat. Now the other side would be the cold side. And so what they do is they put the wall section in there, seal it all up. They've got the heat source, they've got the thermostat, and then they crank down the temperature of the outside to minus 35 centigrade or minus 31 Fahrenheit. And they tested 2 wall assemblies, the ICF wall assembly, and they tested the 2x6 wall assembly. So what happened? Well, this is what happened. The red line's the wood. What this graph is the energy being supplied to the heating unit in the warm side of the chamber to keep it at 70 degrees Fahrenheit throughout the test. The test lasted 14 days, actually. But you can see how with the wood frame wall, the thermostat tripped almost immediately, and energy started being fed into the to the heater almost immediately. And so this is the energy consumed with the wood frame wall. This, on the other hand, is the ICF energy line. As you can see here, the thermostat didn't even turn on for the first 2 days. So minus 31 degrees Fahrenheit on the outside, the temperature did not turn on for 2 days. Then it started as a trickle, and then it started to advance and advance until it actually hit its constant output. So the difference, what this gray area is in fact the energy savings the ICF wall provided over and above that of the 2x6 wall. The 2x6 wall used 149% more power. The ICF wall operated from at a peak of R82 all the way down to R24, R28 in days 19 to 14. So you can learn more about that if you want to read the whole test. But that is essentially the physics behind an ICF wall from a thermal performance point of view. On the Logix ICF website, we have all sorts of, we have this infographic which talks about some of the things that Mr. Heinrich put into his house. And there's other things as well to make your ICF home as high performance thermally as it can be. Anyways, the old meets new net zero home, congratulations. First runner up, large residential. So where do you go from here? Large residential, winner. And this, we'll call it the private urban infill home. And this home is located in Edmonton, Alberta, supported by ICF Forming Inc., local Logix dealer, in conjunction with Western Built Limited, who assisted in the construction of this home, all supported by Carlos Crivero, Logix territory manager for this project. This is an extremely interesting home. This is not built out in the country as many ICF homes can be. This was built right in infill city site, in fact, right near a light rail train station in a reduced width lot. This is the lot. You can see how they had to do a very deep excavation. In fact, they had to shotcrete the sidewalls to prevent caving in. There was no on-site storage. This is in the middle of a neighborhood. No tractor, trailer, truck access. In fact, it's not a very big lot. They basically use the entire lot for the house. So there was so delivery and coordination. This is a very complicated build. Storage, everything had to be very minutely managed. There's the home starting to be built. They use the Logix Pro ICF system. You might want to ask, if they use the whole lot for the house, where's the backyard? And we'll get into that more, but the backyard's actually on a roof level for privacy, and we'll get into that. This house made extensive use of the Fortress ICF floor system that we saw in Dave LeBlanc's home in the Northwest Territories. But they didn't use it just for the garage floor. They actually used the Fortress system for the main floors of the home and actually for the roof as well. In fact, the entire structure of this home is concrete. There's a great shot of the Fortress floor system ready to accept concrete. And there's a shot of it after concrete has been poured into the beam sections of the Fortress floor. We're ready now to then to pour over top of the slab section. Here's a shot of the interior of the home. You can see the Fortress floor system. You can see they've also used radiant floor heat in conjunction with the Fortress floor. So, you know, this is a home, but it's non-standard construction. It's using non-typical construction techniques. This is essentially commercial construction and using unique heating and ventilation systems. So it's very unique. And there's you can see the Fortress system up here too as well. The whole structure is concrete. You can see the different levels of the floor. It's quite a big building. It's 3,600 square foot above grade living, 1,460 square feet in the basement. There's a 650 square foot garage with a 650 square foot mechanical room underneath the garage. and then a couple of roof patios. So there you can see where the roof patios might be up in here and the different levels. There's actually 6 interior levels and 2 exterior rooftop levels, as you can see in this home. It's really unique. There's another shot of the home under construction. Another. This is the 650 square foot mechanical room. There you can see the manifolds for the radiant floor heating. And this is located underneath the garage. Here's a sense of how the house is finished. You can see polished concrete floors. Look at the detailing in the floors, even concrete steps. Okay, this house is extremely low maintenance, zero maintenance. And you can see how they carried the detailing from the outside, the exterior detailing, into the inside to kind of give it that continuity of design. Outside, they used acrylic rock for low maintenance, and interior stone carried out the theme. A lot of shrubbery was around here. There's the back. There's the rooftop deck for privacy. Okay, so that's the top of and the finished fortress floors. You can see here, this is actually a Google Earth view of the location. This is the railway line. This is the home. This is the train station. This is the roof deck right here, the backyard. So you can see how this is. This may have been kind of an undesirable lot in many ways, but the way they designed this and built it, there's privacy, there's efficiency, there's quietness. It's a perfect use it's a perfect design to make great use of an infill lot. There's a shot from the street to hockey nets, which is always good to see in Edmonton. And so a lovely looking home. So congratulations again to the private urban infill home, IC Forming, Westerbuilt Limited, all supported by Carlos Crivero, Logix Territory Manager. To our final category, most outstanding commercial project. First runner-up, a safe haven assisted living facility. And this, if we had a project up in the Northwest Territories, this is on the other end of the scale. This is in near Fort Myers, Florida. Island Coast Distributors is a local Logix dealer providing support to this project. The LaSalle Group is a developer. Mike Russell is the Logix Territory Manager who supported this project. This project was going to be CMU. This was a masonry design building. The local Logix dealer saw this project at his local, in the records, at his local construction association, contacted Mike Russell. Mike Russell contacted the owners, introduced them to Logix and the notion of an efficient, safe haven assisted living facility. They were very intrigued and they said, let's go for it. And so you can see how it's a slab on grade construction. They're not even doing the exterior walls here yet. These are the interior. These are the walls surrounding an outdoor atrium that's within the center of the building, and they were ICF as well. There was a ton of slab work to be done before we could get going here. There's a lot of electrical and plumbing embedded in here. These are 10-foot walls, 6¼ inch Logix Pro Core. The initial design was for CMU. It wasn't with Logix ICF in mind. So we did have some design issues to overcome. There were short 45 and 90-degree corners that we had to overcome on this. We had people on site to assist with the crews. This is Al Peterson, our Director of Commercial Solutions, providing personal service on site. Our local Logix dealer, Island Coast Distributors, they provided a lead hand to work with the crew. The crew who did this install had not built with ICF before. So we had people on site, we had lead hands helping them with the crew, just to get this job to go as well as it did. This project is actually in, as I said, very near Fort Myers, Florida. They've had some real weather events over in the very recent past. Hurricane Irma comes to mind, and you know, the residents did not have to be evacuated, which is very important with an assisted living facility. The energy bills are lower, look to be a lot lower than they would with a typical construction. The developer is really seeing the value of ICF to his business model: more comfort for residents, peace of mind during climactic events, lower operating costs, ability to self-perform on construction. Here's some more shots of the project going up. There's the finishing of it. Lovely looking facility. There we are on the inside, very beautifully detailed inside. So for the Safe Haven Assisted Living Facility, congratulations, first runner-up commercial, Island Coast Distributors, the LaSalle Group, and Mike Russell. To our final project today. Most outstanding commercial project, outright winner, is the Frederick Douglass High School. This project was supported by the Wells Group, LLC, Logix dealer, Gravesco Inc. was the installer, and Travis Kittrell, Logix territory manager, provided the support. This massive project is a 287,000 square foot, $63 million project. It took 100,000 square feet of Logix to build this. This project was won in an open bid, which is the typical method for these type public facilities. For this size build, it was 150 days to build the Logix portion, which is not a ton of time when you consider the scope and magnitude of this build. You're looking at 36-foot high tall walls with gable lines. This used a 12-inch Logix core. This was a winter build. This is after the walls were built, but this was a winter build during a very, very cold winter. The GC reports that had they built with the CMU, which is how these projects can be designed, they thought that there would have been multiple construction stops due to the cold weather. But ICF, as it's insulated, you can keep going even when the temperature is below freezing, and that they did. This school is done to net zero design, very airtight, and ICF was a very economical way for them to achieve net zero. For such a large structure, this structure was built with an 8-man crew. Had it been built with CMU, likely there would have been over 30 people on site. So a small, tight 8-man crew versus a 30-man crew, big difference. That we're showing here, Logix XP1 wall system. Often in projects like this, they want to use ICF, but in some sections they don't want foam on one side. They would like a hard concrete surface, and XP1 is our way, the Logix way of achieving that. If you want to learn more of the Logix XP1, more detail is on the Logix ICF website. This project was finished on budget and on time. It was a success in all ways. It looks beautiful and beautifully done. Here are some more shots. There's the very interesting roof line. There's the thickness of the ICF walls, which provides that really interesting sill effect. So congratulations again to the Frederick Douglass High School, Wells Group, Gravesco Inc., and Travis Kittrell, Logix territory manager. That concludes our Logix Awards for 2018. I want to thank all the winners and all the runners-up. These are fabulous projects, and everybody involved with those projects. I want to thank everybody who submitted their projects for these awards that weren't profiled. We'll see you next year. And thanks to everyone who watched this. We hope you enjoyed it. We hope you picked up some hints and tips for your own projects. So thank you very much. We'll see you again next year.